Good morning, Year 8. I hope you had a lovely week. So this is your second maths task of the week, and as always, you should have completed your 20 questions in the first kind of 20-25 minutes, and then spend the last 20 minutes marking it. Please upload your mark sheet with it visibly stating how many you got out of 20 to show my homework. So, on to question 1 then. It's a little bit of a different sheet this week because we've started the 5th set of sheets, okay? So, first up, we're going to use a little bit of BidMaths. Okay, so this is the same, but this time we've got our multiplication at the beginning, which is nice. So we're going to do 5 times 0.8 to start with. I'm going to make that a little bit easier, so I'm going to times that by 10, or I'm going to move my decimal point forwards once, so I end up with 5 times 8 equals 40. But then I'm going to move my decimal point back one, so I get 4.0. So now I've done my times, I can just do 4 minus 1.7, which equals 2.3 as our final answer there. Okay, on to the next one then. We're completing the ratio. So we've got 5 to 35, but we want to make it 1 to something. So we're always timesing and dividing in ratios, okay? So how did I get from 5 to 1? Well, I divided by 5. So now I've got to do the same on the other side. So 35 divided by 5 is 7. So my answer, this ratio, is 1 to 7. Same for this one then. So we've gone from 4 to something, and this time we've got 1 to 15. So this time it's actually a little bit kind of the other way around, okay? So this time I want to go up, don't I? So how did I get from 1 to 4? Well, I times by 4. So therefore I want to do the same on this side. So I'm going to times by 4. So 15 times 4 is 60. So my ratio would be 4 to 60 as my final answer. Okay, we need to solve this equation then. So as I always say, we want to get all of the numbers on one side and all of the letters on the other side. So let's start by getting rid of this positive 5. So let's take away 5 from both sides, leaving me with 5x on this side, and then equals 3x. So minus 3, take away another minus 5 is minus 8. Up next then, so now I need to get rid of this 3x, don't I? So I'm going to take away 3x from this side. Got to do it to this side as well. So that leaves me with 2x equals minus 8. Oh dear, I've got 2 x's. I only want 1, so I'm going to have to divide by 2. So x equals minus 4. Okay, up next then. So again, we've got x's on both sides. So I think we're going to get rid of this minus 9. So let's get rid of the minus 9. So let's add 9 to both sides, leaving me with 6x on this side equals 51 plus the 9 is 60 minus 4x. Okay, now I want to get rid of this minus 4x. So I'm going to add 4x to both sides. So on this side, that leaves me with just 60. And then 6x plus 4x is 10x. Oh dear, I've got 10 x's and I only want 1, so I'm going to divide by 10 on both sides, leaving me with x equals 60 divided by 10 equals 6. Okay, so x equals 6 there. Okay, so up next for question 7, we've got kind of a new way of wording a question. So I'm going to do it in a different colour just so we can definitely see it. So it's not a graph question, so it says, does the point 4, 4 lie on the line y equals 2x minus 4? So now with coordinates, we always, basically these two numbers represent x and y, okay? Because when you're plotting something on a graph, you find it gives you the x coordinate first and you go along, and then it gives you the y coordinate and you go up, and that's where you plot it, okay? So I know that 4 is x and y is 4. So now that I know that that's x and that's y, all I have to do is put it into that equation and see if it works. So I would do y equals 4, so I'd put 4 equals, and then I need to do 2x, so 2 times x, which is 4, so 2 times 4 is 8, and then minus 4. So 8 minus 4 is 4, 4 does equal 4, so yes, I know that the point 4, 4 does lie on that line, okay, because I've just put the numbers in, the x and y, into the equation, and it works out perfectly. Let's do the same for this one. So this time I know that x is 3 and I know that y is 28. So let's put that into the equation. So 28, because that's y, equals 19 plus 3 times x, and x is 3, and 3 times 3 is 9. So 19 plus 9 is 28, so 28 does equal 28, perfect, all works out, so I know that those coordinates do lie on that line. Okay, so up next it wants us to find the nth term. So the first thing I have to do in this sequence is find out each of these, okay? So I want to find out what the difference is between each of these steps. So I am adding 2 each time. So if I'm adding 2, that's my rule, that goes first. So a positive 2, and then I put n. Okay, so then I've got to ask myself, how do I get from 2 to the first number? Well, I don't have to do anything, so my answer is simply 2n. I can try it for the fourth number. If I put 4 in there, I would do 2 times 4 equals 8, so I know that I'm correct. Here, what's the difference here? Well, we've got minus 6 each time. So that means I'm going to put minus 6n. Now, how do I get from minus 6 to the first number in the sequence? Well, I'm going to have to plus 6. So let's test that on a number. Let's test it on the fourth one again. Minus 6 times positive 4 is minus 24, and then plus 6 is minus 18. So I know that that is also the correct answer. I mean, you could have also written it as 6 minus 6n if you didn't like your minus at the beginning. Okay, so next up, we've got another graph question. Okay, so it asks you to find the gradient of the line 2y equals minus 6 plus 1. So this is a bit different to normal, because normally we just have y equals something. So we're going to have to get it down to y equals something. So I'm going to have to divide everything by 2, because I've got 2y here. So if I divide this side by 2, I get my desired y on this side. But I'm going to have to divide this by 2 and divide this by 2 as well. So that means I get minus 3x plus 0.5. So now it looks right, doesn't it? It looks like y equals mx plus c. And I know that my gradient always comes from behind the x, don't I? So I know that this is where the gradient goes, okay? So therefore my answer is minus 3. That's the gradient of that one. Okay, so same thing here. This time it's even worse. So I've got 3y equals 12x plus 15, but I only want 1y because that's how it works. So I'm going to have to divide by 3 on this side to get y equals, and then I'm going to have to divide by 3 on this side as well. So I'm going to have to divide this one and this one by 3. So that means I get 4x plus 5, okay, because I've divided both of those by 3. So now, as we said a second ago, we know that the gradient is always behind the x. So my gradient is here, so that's my gradient. It's a very dodgy looking number 4, okay? All well and good me showing that, but had I read it properly, that's not even what the question asks. So let me just get rid of that, although, you know, it's always good to do things twice. The question actually asks you, find the y-intercept of the line 3y equals 12x plus 15. Now, we still needed to do what we just did, so silly me should have just left it, but I'll have to do it again now. So we're going to divide by 3, just like we did. So that leaves us with y equals 4x plus 5. Okay, perfect. But it actually asks you for the y-intercept. So the y-intercept is here, isn't it? So it's plus 5. So therefore the answer would be 0, 5, okay? Because obviously x is, we don't know what x, when you're on the y axis, obviously x is always 0, and we know that the y-intercept is always this number. So it's 0, 5 for that one. Always read the question. That's the moral of the story there. Okay, on to the next one then. So it wants us to express 16 out of 40 as a percentage. Okay, so first of all, let's write it as a fraction. So we've got 16 out of 40. Okay, so now this is how I would do it. So let's get it nearer to 100. So let's do, so if we times by 2, we're going to get 32 out of 80. But I want to add on whatever remaining is there. So I want to add on, I'm going to have to half this as well. So if I divide by 2 here, then I would get 8 over 20, wouldn't I? Yeah, so now I know that 16 over 40 is equivalent